Hi, good afternoon, everyone. Today we are going to go ahead and do probability, the types of probability distributions, and towards the end, we will do hypothesis testing, sampling and hypothesis testing. With that, we will wrap up statistics completely. जो भी stats we did yesterday, I have gone ahead and posted an assignment based on that stats on your portal. The assignment contains 199 questions with answers. So go ahead and attempt that assignment. It has questions based out of whatever topic we covered yesterday. Chahe it is correlation, chahe it is simple regression model, whether it is mean, median, mode, whatever. Based on all of that, there is an assignment on your portal just below the lecture. Go ahead and do that assignment. Okay, so let's begin with probability. Again, one last time, I'm requesting whoever has not updated their name, please go ahead and update your name to the name with the batch name. ठीक है जी, let's start. So we are starting with probability first of all today. Sorry, I missed one question before we go ahead. Yes, we will wrap up IIT JAM paper this week. We'll do it this week, and I will give you a time for that. But we'll make sure that in another 2-3 days we wrap up that because only that paper is left. Then we'll do ISI ka paper only once CUET paper is over. Then we will go ahead and we'll look back at the ISI 2025. Okay. Okay. Now let's go ahead and one more question. If we have to find first decile, then we will take 0th term in the case it comes out as 0.9. No, you will take 0.9 times first minus 0th term. Right? Like for 1.9, we do 1 plus 0.9 second minus first term. For 0.9, you will do 0.9 first minus 0th term. So there is no 0th term. So just first term ka 0.9. Okay. Okay. Okay, so let's go ahead and begin with probability. देखो, probability is by far the most tricky topic statistics में, and it is one most commonly asked topic. So whether it is IIT, GATE, CUET या फिर ISI, probability is most often asked topic, but the difficulty level keeps on changing, right? So first of all, let's go ahead and let's understand how to find out the basic probability. All of us know that whenever we have to find basic probability, it is number of favorable events upon total number of events. This is the foundation of probability. ठीक है? इसमें you need to understand some definitions. जैसे for example, I need to understand what is random experiment. Random experiment क्या होता है ना? तो random experiment is any experiment whose outcome cannot be predicted. अगर मैं किसी चीज का outcome ना बता पाऊं, if I cannot say whether it will be some certain thing with certainty, जैसे tossing a coin, it can either be head or tail, either or लग रहा है, right? So we cannot tell with certainty what the outcome will be, so that is a random experiment. Then we need to understand what is a sample space. Sample space माने all possible outcomes. So when I toss a coin, what will be the possible outcome? Head हो सकता है, tail हो सकता है. When I toss two coins, what are the possible outcomes? Both can be head, both can be tail, one head, other tail, one tail, other head. Right? So this is a sample space, including all possible outcomes. वो एक sample space होगा. Then the third one, it is basically any event. So event is we can call it as a subset of sample space. जैसे event can be getting two heads. तो sample space में सब कुछ आ रहा है. It includes everything. Both can be head, both can be tail, head, tail, tail, head. but event is getting two heads. And similarly, event can be getting two tails, and so on and so forth. Okay. Now, there can be two type of events. One can be called as simple event, and एक को हम बोल सकते हैं, one can be called as a compound event. Simple event माने any event which has a single outcome. ठीक है, जैसे this, getting two heads. It has a single outcome, एक ही outcome है HH. But compound event is any event which can have more than one outcome. Just if I say that my event is getting at least one head. So I know that the first can be head, second can be tail, first can be tail, second can be head, both can be head. So at least one head में one head भी आता है, it includes one head also and it includes two heads also. तो माने it becomes a compound event because it has more than one outcome. ठीक है. Anything which is an impossible event, माने there is no possibility of it occurring, it means that it will be a null set. It will be 5. Right? And anything which is a sure event, कि 100% यही होगा, it means it will be the entire sample space. Right? 100% something will come out of the sample space. Now, whenever we talk about probability, ठीक है, the classic definition of probability, वो कहता है, it is number of favorable events upon the number of total number of events. And total events is nothing but the sample space. So in the denominator, you will simply have the number of events in the sample space. Mane, if I have to find probability of two head, right? So number of favorable event by total number of events. So total number of events we can see as 4, and two head is only coming one time. So the probability becomes 1/4. Now, post this, हमें जानना होता है what are the axioms related to probability. So when we talk about the axioms related to probability, सबसे पहला तो बहुत ही basic है. It's a very basic axiom that probability cannot be negative. So probability of any event has to be greater than equal to 0. The second is that the probability of entire sample space is 1 because it includes all possible events. The third is that we can also define something and we can call that as mutually exclusive events. And mutually exclusive events वो events होंगे which have nothing in common. Those events which have nothing in common, जिनमें कुछ भी common नहीं है, they can be called as mutually exclusive. They exclude each other. And to understand mutually exclusive events, what we can do is we can learn a bit about the algebra of probability. So we know that when we go to set theory, A union B is A plus B minus A intersection B. And in probability, we just use P everywhere. This is also true for probability. Similarly, we know A union B union C is A plus B plus C minus A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C. तो if it is probability, हम हर जगह पे probability लगा देंगे. These two become the algebra of probability. ठीक है. Now when we say that the events are mutually exclusive, That means that there is nothing common between these. Matlab, if A is this, then B will be this. They have nothing common in them. उनका कोई भी common part नहीं है. So if there is nothing common between them, it means that A intersection B. A intersection B means the common part. That becomes 0. So probability of A intersection B, that is 0. This set is a phi set. It's a null set. So if I put here 0 for mutually exclusive events, क्या आ जाएगा? What will I get? Probability A union B will be probability of A plus B minus 0. So I'll simply get A plus B. So we can say that for mutually exclusive events, जब हमारे events mutually exclusive होंगे, we can go ahead and say that probability of the union, this is nothing but the sum of the probabilities. Probability of the union is nothing but the sum of probability. Is it clear? Any doubt in this? Anyone? Okay. Now we can go ahead and now we can talk about some of the results related to the derived results related to probability. इसमें सबसे पहला thing that we need to understand is what is complementary set. A complementary set is any set which is other than the set itself. माने if this is A and this is the entire sample space, so anything other than A, that is my A complement. So we can say that A complement is nothing but sample space minus A. So if I include probability on both sides, probability of A complement will be probability of sample space minus probability of A, and sample space ka probability is 1. So probability of A complement becomes 1 minus probability of A. Okay. Again, if I can say that if A is a subset of B, right, then because A is within B, the probability of A will always be less than equal to probability of B, right? Let's go ahead. Let's take a numerical, then we'll move forward. So quickly, very simple question I'm giving you. All of you give it a try. The probability of A is 0.6. Probability of B is 0.5. Probability of A union B is 0.8. Find probability of A intersection B, part number A, and part number B. Find probability A union B if A and B are mutually exclusive. This is A, huh? Part A starts from here. This information is only for part A. This is part A. This is part B. Do it. Okay. Good. Very good. All of you are right. So basically, we can go ahead and do the first part easily using the formula of union and intersection. So we will go ahead and get that probability of A intersection B will be 0.6 plus 0.5 minus 0.8, right? So you will get the answer as 0.3. And in the other part, because A and B are mutually exclusive, mane A intersection B will be 0. So A union B will become A plus B. So it will simply be 0.6 plus 0.5, which will be 1.1. So all of you are correct. Okay. Okay, now let's go ahead and move on to the next part. So now we want to go ahead and we want to, because this includes two, right? This is union. Take it. Now we want to talk about conditional probability. The conditional probability is probability of A given B is probability A intersection B upon probability of B. Conditional probability basically goes ahead and tells us what is the probability of A given that B has occurred. B हो चुका है, तो B के होने के बाद A का क्या probability रहेगा, that is what conditional probability goes ahead and tells us. ठीक है. अब in this, I want to introduce a new term which is called as independent events. Independent events are those events which are not affected by the occurrence of another. माने B के हो जाने से A को अगर फर्क ना पड़े, if A is unaffected after the occurrence of B, then A and B will be independent, right? So what is independent event? If A is not affected after the occurrence of B, like I tell you one event is raining, right? It is rain or no rain. Another is whether I get head or tail on a coin. There is no connection between the two. So if one event is not dependent on what happened with the other event, then they can be called as independent event. तब हम उनको independent event बोल सकते हैं. Independent event means that probability of A given B has occurred is simply probability of A. So that means A is not concerned with occurrence of B. B given B occurred does not matter. It is simply the probability of A. Okay? So conditional probability is same as actual probability. A को कोई फर्क नहीं पड़ा कि B हो गया. A was unaffected that B occurred. So probability A given B occurred is same as probability of A. Now in this case, what we can go ahead and do is, suppose if I have to write that A and B are conditional event, so probability A given B occurred will simply be probability A. And from here, if I take it here, I will get probability A intersection B as A into B. So this is another formula of independent event, that when two events are independent, अगर दो events independent हैं, then probability of A intersection B will be probability of A into probability of B. ठीक है? So please remember that mutually exhaustive and independent are two different things. दोनों का मतलब अलग है. Mutually exhaustive goes ahead and says that probability A intersection B is 0. This is exclusive. This is mutually exclusive. They have nothing in common. Whereas this is independence. So both are different. Exclusive says they have nothing in common. उनमें कुछ भी common नहीं है. Whereas independent says that probability A intersection B will be A into B. Now here we have another term, which is mutually exhaustive. Exhaustive means that they take the entire sample space. These events make up the entire sample space. जैसे, for example, if I tell you event E1 is getting a head and event E2 is getting a tail, and I am tossing a coin. So does E1 and E2, are they exhaustive? Answer is yes. Because there are only two things, ya head, ya tail. And E1 and E2 together, it is equal to the sample space. Kuch bacha nahi hai. There is nothing left. But suppose if I tell you that I have tossed two coins and E1 is getting two heads and E2 is getting two tails. So are they exhaustive? Answer is no. Because what is my sample space? Two head, two tail, head, tail, head. So do the event E1 and A2, do they exhaust the entire sample space? क्या उसमें सब कुछ include हो गया? Have they included everything? No. So exhaustive means that when I write these events, do they include the entire sample space or not? Is it clear? So three definitions you have to remember. They will be asked in MCQ इस तरीके से that you will get confused. So mutually exclusive, nothing in common. Independent, A intersection B is A into B. And exhaustive means they should take the entire sample space. Now, if probability A given B is A intersection B by B, तो probability B given A is A intersection B by A. ठीक है? So here we will reverse because it is B given A, तो यहाँ पे we will have A in the denominator. A given B में we will have B in the denominator. Take a question, try to solve this question. Question. Probability A given B is 0.6. Probability B given A है 0.4. Probability A है 0.5. Find probability B. Give it a try. Okay, how about others? ठीक है, all of you are right. Good. तो देख लेते हैं एक बारी. So this means that probability A given B is probability A intersection B upon probability of B. And this means probability B given A is probability A intersection B upon probability of A. Now this is given to me as 0.4 and this is given to me as 0.5. So probability A intersection B will be 0.4 into 0.5. I can put this here, 0.4 into 0.5 upon probability of B, and this is given to me as 0.6. This is equal to 0.6. So probability of B will be 0.4 into 0.5 by 0.6. So 2 by 3 into 1 by 2. 1 by 3 is the answer to this question. ठीक है, all of you are correct. ठीक है जी. So tell me if this statement is true or false. If A and B are independent, then first A and B complement are independent. Second, A complement and B complement are independent. Third, A complement and B are independent. Fourth, A complement and B complement are dependent. You have to tell me कौन से statements true है, which of them are true and which of them are false. Yes. How about others? Okay, B true, D false. What about statement A and B? A and C? Okay, so let's see. So it says A and B are independent. That means you're given that A intersection B is A into B. This is given to you. And it is saying, what about A and B complement? That means you have to tell me, what about A intersection B complement? What about A intersection B complement? So how can we go ahead and how can we show this thing? How can we think whether they will be independent or dependent? Can you go ahead and can you think about some way to prove that the two sets are independent mathematically? If not, can you think about a way in which you can use some numbers to prove it? So here, proof is not required. End में जो ये results आएंगे only they are important for you. But I am just giving you proof of one of them. So usually what happens is whenever we have any set A can be written as A intersection B union A intersection B complement. Any set A can be written like this, right? So probability of A will be probability of A intersection B union probability of A intersection B complement, right? And union means that we always go ahead and we always add. In terms of probability, kahin likh lo, union means addition. In terms of probability, union means addition and intersection means multiplication. Okay, so because it's a union, I have added. Now I need to find probability of A intersection B complement. So it will become probability of A minus probability of A intersection B. And this will be probability of A minus probability of A into B. Because it is given that these are independent events. ये मुझे given है. Right? So I have just gone ahead and done this. Now I can take probability of A common. So when I go ahead and when I take probability of A common, I get 1 minus probability of B, and this becomes probability of A into probability of B complement. So this is the proof that these are independent. Similarly, you can prove others also. So actually, this is a true statement. This is a true statement. This is a true statement. And this is false. Whenever A and B are independent, अगर A और B independent हैं, तो A and B complement भी independent है, A complement and B complement भी independent है, A complement and B भी independent है. All of them will be independent of each other. Okay? So this is important for you to use in your exam, because sometimes they will ask you find, just for example, if I go ahead and do something like this, suppose if I tell you that probability of A is 0.4. Probability of A intersection B complement is 0.5. Find probability of B if A and B are independent. ऐसा कुछ क्वेश्चन है, ठीक है? तो क्या करेंगे? What will I do? I know that I will use this property कि if A and B they are independent, then A complement and B complement भी independent होगा. They will also be independent. So if A complement and B complement, A and B complement will also be independent. So A intersection B complement को I can write A into probability of B complement, right? And probability of A is 0.4 and this is given to me as 0.5. So यहाँ से I will find probability of B complement. That I will get as this. 0.5 by 0.4. Of course, because I made this question myself, you're getting more than one. होना नहीं चाहिए. हाँ, probably I can take this as 0.3. Then it will make more sense. Okay. So you will get probability of B complement as 3 by 4. So then you can get probability of B as 1 minus 3 by 4. That means 1 by 4. है ना? So this kind of question can be asked उसके application पे. So you have to remember that whenever they say कि A and B are independent, it automatically means that A and B complement ये भी independent है. It means A complement and B ये भी independent है. It means A complement and B complement this is also independent. So any of the one value will be given to you. I know कि I can open and write it as a product. मैं उसको as a product ऐसे I can write it down. Is it clear? Any doubt in this? Is it making sense? This is a very commonly asked question. माने directly they will not give you A intersection B always. वो इसको थोड़ा इधर उधर करके भी they can go ahead and they can give you. Okay, ठीक है. Now we will go ahead and we will move on to De Morgan's theorem. De Morgan नहीं, sorry, De Morgan. De Morgan is in complex number. De Morgan's theorem. De Morgan theorem में पहला theorem है that probability of A union B का complement is A complement intersection B complement. Right? This is the first theorem. The second theorem is A intersection B complement is A complement union B complement. ये भी sometimes it will be useful for you to use these in exam. ठीक है, just keep these two in mind. Now the next thing जो probability में आता है that is basically on your Bayes theorem. ठीक है, most important, and I can guarantee that there will be 1 to 2 questions on Bayes theorem every year in your paper. इसको अच्छे से प्रैक्टिस करना है हमें. So Bayes theorem basically is to go ahead and to find out the probability using the concept of total probability. ठीक है, तो हमें बहुत सारे छोटे छोटे इवेंट्स दिए होंगे. These events will be partial events, right? पूरा सबस्पेस का एक एक इवेंट will be given to us, and using those events, जो partition events होंगे, we have to find the probability. So the formula for Bayes theorem is probability of AI given B is equal to probability B given AI into probability of AI upon summation of probability B given AJ into probability of AJ, and J goes from 1 to N. I'll give you some examples, then it will become clear. तो हमारा जो first question है based on Bayes theorem, it is basically, let's say that there is a chance of catching disease which is 2%. Okay. Whenever you catch a disease, the test shows accurate results 95% of the time, and it shows false positive 5% of the time. Okay. Find the probability that the person has disease given he tested positive. Given he tested positive. अब देखो ये क्या कह रहे हैं. This is saying test accuracy is 95% of the time. माने that given you have a disease, ठीक है, the test will be positive 95% of the time. And given you don't have the disease, no disease, you will get a positive result. इसका probability है 5% of the time. And probability of getting a disease, ये है 0.02. Question is asking, find, given that the person, find the probability person has disease given he tested positive. माने उल्टा, given he tested positive, given P, given he tested positive, find the probability of disease. This is what you have to find. So in such questions, what we will do is, we will notice that always the reverse is asked. देखो, इसका reverse is being asked, right? So this is a very big hint कि हाँ यहाँ पे Bayes use होगा. The reverse question is being asked. So we will use the formula. Probability of D given P will be, numerator will become probability of P given D into probability of D, and denominator में we will take all possible cases. माने probability of P given D into D plus probability of P given no D into probability of no D. So denominator will always have total probability. ये वाला भी include होगा, positive given disease into disease and positive given no disease into no disease. Denominator will have both. And numerator will always be, you will notice, opposite of this. So if it is asking disease given probability, it given positive, so it will become positive given disease into disease. So just solve this and tell me the answer to this one. Just solve this. $0.279. ठीक है. If all of you are getting that, then that's the answer. तो यहाँ पे हम लिख सकते हैं So given disease positive has 0.95, getting disease is 0.02. Given disease positive has 0.95, getting disease is 0.02. No disease positive has 0.05. And probability of no disease will be 1 minus probability of disease, 1 minus 0.02, 0.98. Just solve this and get the answer to this question. Okay. Okay. So one more question we'll do and then we can move on to the next topic. So write down the question and try to do it. So you have that there is a factory which has 3 machines, right? And machine 1 makes 20% of the items and the defective rate is 1%. Machine 2 makes 30% of the items. The defective rate is 2%. Machine 3 makes 50% of the item और जो defective rate दिया हुआ है वो 3% है. अब हम बोल रहे हैं an item is found defective. Find probability it was produced by machine 3. So Bayes theorem जब भी use होगा, wherever Bayes theorem will be used, you will notice that they're giving you a statement like this, that a person was found having disease, an item was found defective. And then they will ask you the reverse probability. Ki, given that this happened, given that he had, the item was defective, what is the probability machine 3 produced it? Hanji, tell the answer to this one. तो देखो ये डिफेक्टिव 1% का क्या मीनिंग है दैट गिवन मशीन 1 ने प्रोड्यूस किया प्रोबेबिलिटी ऑफ डिफेक्टिव दिस इज 1%. डिफेक्टिव माने गिवन मशीन 2 में से आया व्हाट्स द प्रोबेबिलिटी ऑफ डिफेक्टिव. यहां पे गिवन मशीन 3 से आया व्हाट इज द प्रोबेबिलिटी ऑफ डिफेक्टिव. एंड व्हाट इज द क्वेश्चन आस्किंग. क्वेश्चन बोल रहा है दैट given defective, I already know जो item है that's defective. Given defective, what is the probability of machine 3? I picked up an item, मैंने एक item निकाला, वो defective already था. अब हमें निकालना है the probability that it was produced by machine 3. बस put it in the formula, solve it. Okay, just do it. तो ये this will reverse, ये बन जाएगा D given M3 into M3 and denominator में all will come. So D given M1 into M1, D given M2 into M2, D given M3 into M3. तो D given M3 into M3, D given M1 into M1, 20%, 0.20. D given M2 into M2, 30%. D given M3 into M3. Just solve this. Okay, I hope this is clear to everyone. Is there any doubt? क्योंकि ये एक short question है which will be asked in exam. And disease and machine based questions are very very common. So you have to make sure कि ये अच्छे से आ जाए. Okay. Now the next thing that can be asked in exam that is basically related to permutation and combination. ठीक है. Now, question is asking that where, first of all, where should be used permutation and where should we use combination? Permutation is used wherever arrangement is important. माने wherever order matters. Permutation का formula होता है, the formula is NPR is equal to n factorial upon n minus r factorial. Combination is used wherever the order does not matter and only जो matter करता है that is selection. Right? You have to select. Like you have to make a committee. 4 out of 10 people, committee of 4 people. But it does not matter किस order में. Right? पहला male हो या second male हो, पहला female हो या second female, does not matter. The order does not matter. Right? You just need to select few people out of bigger people, then it is combination. And combination में the formula is NCR is equal to n factorial, r factorial, n minus r factorial. Okay. This let's think of some questions. First of all, basic permutation combination के. So if I tell you arrange 3 students out of 5 students on a stage. Right. So I am saying that here the order matters. Mane, if there are 5 students, A, B, C, D, E, I have to arrange them. I have to take 3 students and arrange them. तो यहाँ पे order matter करता है. Whether I take A first or C first, these will be different arrangements. ये अलग हैं. The order matter. So A sitting in the first place and then B and then C, ये एक अलग arrangement है. It's a different arrangement. And C sitting first and then B and then A is different. And D sitting first and then A and then E is different. So each of them is different. Right? So arrangement matter कर रहा है. Here arrangement is mattering. Then we will use permutation, and permutation का formula will become NCR. So it will be NPR. So it will be 5P and I need 3 students at a time. So 5 factorial by 5 minus 3 factorial. So 5 factorial by 2 factorial. So you have 5 into 4 into 3 into 2 by 2. And this will go ahead and give you 60. Right? Exactly. So ये हो गया हमारा first thing, that the order matters. In combination, the order does not matter. So if I just, same question में, if I would have said, I need to select 3 students out of 5 for stage. So now I just have to pick 3 students. Now A, B, C and C, B, A, these are same. Because ultimately I have selected the same people. Okay. So whether A was selected first and then B and then C, या पहले C select हुआ and then B and then A, does not matter. Because I just wanted 3 students on the stage. But here I wanted to arrange students. Now, तो यहाँ पे it mattered. ABC was not equal to CBA. Both are different. But here both of them are same. So we have to understand that when we talk about combination, combination is just selection. So NCR, so it will be 5C3. So 5 factorial, 3 factorial, 2 factorial. So this will be 5 into 4 into 3 factorial by 3 factorial, 2 factorial. So 3 and 3 cancel and this will give me 10. So there are 10 ways to select student, but 60 ways to arrange student. अब एक बहुत interesting aspect है यहाँ पे. The aspect is to go ahead and to find the relationship between permutation and combination. So if I notice, I know that NCR is n factorial, r factorial, n minus r factorial. And I know कि ये वाला जो part है n factorial upon n minus r factorial, This is nothing but permutation. ये permutation का formula है. So I can go ahead and I can say that NCR is equal to NPR by R factorial, and I can take it here. So NPR will be R factorial into NCR. This is the relationship between permutation and combinations, and sometimes it can be asked in exam. Okay, let's quickly take some questions around it. So question number 1. How many ways can you arrange the words, or actually alphabet, in statistics? Okay. How many arrangements of the word statistics? Okay, अब देखो. In this question, they didn't say कि pick, तो permutation directly नहीं लग सकता. Like here we said that select or arrange 3 out of 5. So out of 5, 3 were required. But here it is not saying this. I need to arrange all alphabets, right? But just tell me, if I write S, this is my first S, and this is my second S, and this is my third S. When I write first S followed by second S followed by third S, then TATITIC, ये मेरा first S वाला, I have written it here. Or whether I write my second S first and then my third S and then my first S, do they look different? No. तो आई कैन नॉट डिस्क्रिमिनेट. मैं इस चीज में नहीं डिस्क्रिमिनेट कर सकती दैट वेदर आई हैव रिटन माई फर्स्ट एस फर्स्ट, या आई हैव रिटन माई सेकेंड एस फर्स्ट, या आई हैव रिटन माई थर्ड एस फर्स्ट. S will look like S, isn't it? So these two will be the same only. These two will be the same. So because there are 3S, 3S आ रहे हैं, I cannot tell someone कि no, this here, this and this are different, क्योंकि यहाँ पे I have my first S coming first and यहाँ पे I have my second S coming first. That's not something that happens. So in such questions, we look at the repetitions because those repetitions look similar. Whether I put my first S first and second S second पे, या second S first position पे and first S second position पे, it looks the same. So what we go ahead and what we do is, whenever we have repetitions, the formula is n factorial upon whatever is getting repeated factorial. So I notice that S is coming 3 times, T is coming 3 times, I is coming 2 times. Any other alphabet repeated? No. So we can go ahead and we can change here and we will go ahead and get the answer. Total number of alphabets 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 alphabets can be arranged in 10 factorial ways. But because S 3 बार repeat हो रहा है and we cannot discriminate, so divided by 3 factorial, divided by 3 factorial of this, divided by 2 factorial of this. Okay, whatever answer you get here, that is the answer to your question. Is it clear? Okay, so you will not say just 10 factorial. वो गलत होगा. You will have to look at the repetitions also. Okay. Now the next thing that we can go ahead and जो हम यहाँ पे देख सकते हैं, that will be circular permutation. So when we go ahead and when we talk about arrangement around a circle, तो arrangement around a circle is the formula is n minus 1 factorial. माने suppose question बोलता है कि arrange 6 people around a circular table. So whenever we define a circle, जैसे line है, हाँ, so line में I know the starting point, that this is my starting point and this is my end point. There is a starting point to line, but circle में there is no starting point. तो circle में what we need to go is we need to keep one point as the starting point. So we hold one position as my starting point. Right? This is important. So, and we can arrange the remaining position. So when I fix the first position, with respect to which हम बाकी positions को define करेंगे. So there are 6 people. I fix one of them and then I go ahead and I talk about the remaining 5 of them. ठीक है? So therefore 6 people can be arranged in 5 factorial ways. 5 factorial is 120. ठीक है? So this is how we can go ahead and we can define how to arrange around a circle. ठीक है? Now there is another important thing here. So for example, if someone tells you that arrange clockwise या arrange anti-clockwise, right? So remember कि clockwise and anti-clockwise arrangements are same mathematically. Whether I have to arrange them clockwise या whether I have to arrange them anti-clockwise, it does not matter. एक ही बात है, चाहे आप clockwise चलो या anti-clockwise चलो, both of them are the same thing. ठीक है? Okay, so solve this question. How many ways to arrange 5 people A, B, C, D, E if A and B always sit together? Give it a try. This is question number A, and second भी लिख लो, if A and B should never sit together. Okay, how about others? अच्छा, so just one thing here, just keep in mind कि अगर वो एग्जाम में पूछे सर्कुलर में distinct arrangements, distinct मतलब unique arrangements, number of unique arrangements, then the formula will be n minus 1 factorial by 2. ठीक है? Why? Just tell me something, हाँ? जैसे for example, I begin circle में ऐसे, that A is here, there are 3 people, B is here and C is here. ठीक है, this is my first thing. I have gone clockwise, right? I gave A, B and C, and if I go like this anti-clockwise, A is here, B is here and C is here. I go like this. These are the two arrangements that we have. So if someone asks you, okay, tell how many arrangements are possible. So you will tell me, ma'am, two arrangements are possible. And you will also tell me, ma'am, ये बहुत simple था. 3 minus 1 factorial हुआ. So 2 factorial, so 2. No problem. Right? But if you look from a layman's visibility, अगर आप जाके normally देखो, you will notice that from a layman, if I ask you that, okay, who two people are sitting together, तो आप बोलोगे मैम A and C are sitting together, वो तो यहाँ पे भी हो रहा है. मैम B and C are sitting together, वो तो यहाँ पे भी हो रहा है. मैम A and B are sitting together, वो तो यहाँ पे भी हो रहा है. So you will notice that you will never be able to discriminate between the two. When three people are sitting in a circle, जब तीन लोग circle में होंगे, you will notice यहाँ पे भी A and B are sitting with each other here also. B and C are sitting with each other here also. A and C are sitting with each other here also. So when someone asks you find distinct number of arrangements in a circle, ये दो actually will be the same. You make three people sit, you cannot tell the difference. ठीक है, आप एक एंगल से देखोगे वो सर्कुलर लगेगा, एक एंगल से एंटी सर्कुलर. So in that cases, if someone asks you find distinct, because such arrangements are the same only, there is no distinction. माने just think about it, no? इसको अगर मैं थोड़ा सा सर्कुलरली रोटेट कर दूं, and if I just rotate it a bit like this, ऐसे सर्कुलरली रोटेट कर दूं, you will get exactly this. Because it's a circle, I can always rotate it. So it means these two are same only, this arrangement and this arrangement. So when someone asks you find distinct arrangements, you always divide by 2. ताकि आप distinct arrangements निकाल पाओ. So actually these and this is the same thing only. Right? So number of distinct arrangement will be total arrangement divided by 2. That means only 1. ठीक है, just keep this in mind कि एग्जाम में if they ask you find the distinct number of arrangements, तो वो हो जाएगा n-1 factorial by 2. And if they ask you find total number of arrangements in a circle, then it will be n-1 factorial. ठीक है. Okay, coming back to this question. Now it says A and B always sit together. तो A and B when they always sit together, अगर ऐसा कुछ बोल रहे हैं, it actually goes ahead and it means that A and B should be considered as one unit. क्योंकि within them, you can think of two things कि ठीक है A first and B second या B first and A second, but they are always one unit. इनको हमेशा एक साथ place करना है. So if there are 5 places and I place A here, so B can be here or here. They have to be always together. They have to be considered as one unit. So जब भी ऐसा क्वेश्चन आता है that A and B are sitting together, it means that A and B must be considered as one unit, right? So A and B together is 1. And अगर मैं A and B को eliminate कर लो, so C is the second one, D is the third one, and E is the fourth one. So ultimately, I have 4 factorial ways in which this can be arranged. AB को I will consider 1 क्योंकि हमेशा एक साथ चलेगा. C is another, D is another, and E is another. And AB within themselves can be arranged in 2 ways. पहले A बाद में B या पहले B बाद में A. So AB among themselves can be arranged in 2 factorial ways. So the total number of arrangements possible will be 4 factorial into 2 factorial. Whatever this answer is. So 4 into 3 into 2 into 2, this will be 12 into 4, 48. And अब ये बोल रहा है second part में that A and B never sit together. Right? So it means ये तो बहुत simple है. This is nothing but total minus A and B sitting together. ठीक है. So total number of arrangement क्या है? There are 5 people, who needs to be arranged. So total will be 5 factorial ways. Minus a and b together ka I have already found out 48. So 5 factorial ka value we know is 120 minus 48. This will be 70. So a and b together it will be 48 and a and b not together will be 72. And अगर मेरे को इसी को probability में convert करना हो, so probability of a and b together will be 48 divided by total, and probability of a and b not together, it will be 72 divided by total. No, this is not circular, na? I'm sorry if it seemed like that. This is just arrangement of 5 people. This is another application that I was teaching. Circular नहीं है ये इस केस में. Is it clear? ठीक है. Now let's move on to next question. So from 7 men and 5 women, select. Let's form a committee of say 4 people with at least 1 woman. Arrangement नहीं है, selection है. You need to select 4 people with at least 1 woman. Do it. At least 1 woman माने you can have 1 woman, you can have 2 women, you can have 3 women, and you can have all 4 women, because you need a committee of 4 people. है ना? So 1 woman का निकालो, 2 का, 3 का, 4 का, the better will be you find total minus no women. So you will get the answer for at least 1 woman. So what are the total number of ways in which I can make a selection of 4 people? Bhai, total people are 12 na? 7 plus 5, there are 12 people. So out of 12, I need to select 4. 12 C4. And now I don't need any woman. माने सिर्फ men में से मुझे 4 select करने पड़ेंगे. I don't need any women. So all 4 have to be men. So minus 7C4. This will be at least 1 woman. Is it okay? This is your answer. You have to select 4 people with at least 1 woman. देखो ध्यान से समझो. When we say find, you should have 1 woman. माने you need 3 men and 1 woman. ऐसे भी कर सकते हो. So 3 men का मतलब क्या है? That out of 7, I need 3 and मतलब multiplication. Out of 5, I need 1. 2 women का मतलब क्या है? That out of 7 men, I need 2 men. And out of 5 women, I need 2 women. क्योंकि I need to select 4. 3 women का मतलब क्या है? That out of 7 men, I need 1 man. And out of remaining 5, I need 3. And all 4 women का मतलब क्या है? That out of 7 men, I don't need any man. And out of 5, I need 4. And क्योंकि ये भी, it can be this also, this also, this also, this also, माने you will add all cases together. तो ये कॉम्प्लिकेटेड है बिकॉज आई एम एडिंग 4 केसेस टुगेदर. तो बिकॉज ऑफ दैट अब हम क्या कर रहे हैं, वी आर सिंपली फाइंडिंग टोटल नंबर ऑफ केसेस माइनस दैट ऑफ नो वुमेन. सो दिस विल बी एटलीस्ट 1 वुमेन. ठीक है, प्लीज अंडरस्टैंड इट वेरी वेल. ये क्वेश्चन एग्जाम में आएंगे. यू विल गेट दीज क्वेश्चंस इन एग्जाम. ओके, सो दिस इज कॉम्बिनेशन एंड परम्यूटेशन. अभी हम नोट्स पे एक बार देख लेते हैं. यू हैव टू रीड ऑल ऑफ दिस. एवरीथिंग इज मेंशन्ड. व्हाट इज कॉम्बिनेशन, परम्यूटेशन, some rules are mentioned here. Do these rules. Conditional probability base, some numericals I have given here. Do these numericals kar lena. Now I will talk about probability distribution. देखो, when we talk about probability distribution, so there are two kind of probability distributions. ठीक है, the first kind of probability distributions are discrete. आकाश, आप भी तो मेरा इग्नोर कर रहे हो. इवन आफ्टर टेलिंग यू 100 times टू राइट योर बैच नेम, द बैच नेम इज मिसिंग. Secondly, what's the doubt that you have posted which has been ignored? I'm not even sure if you belong to the batch or you have the link of someone else. Where is your doubt? Can anyone notice any doubt in the chat window from Akash? Yes, he is. And you know what? This is all, I don't know why people are doing this, but this is just to distract all of us. Because I am the only person in the entire industry who's taking so much effort. So there are people who come, who write messages, they write personal messages in the Zoom the entire day, let me tell you. And I'm fed up with all of that. There are people who are writing random messages on Telegram. There are people who are writing random things on my YouTube channel. And day in and day out, I am taking care of all of that without hampering the marathons. And believe me, within seconds, such people will then exit the Zoom. So yes, dear Akash, if you really have the guts, please switch on the video and tell me what's the doubt that has been skipped. See, no reply. That's why I request all of you to put the name of the batch so that the team can check if you actually belong or there are random people on the Zoom. Now, this is just a wastage of my time and yours. I understand I have to learn better. Everyone learns with time. I will learn with experience, but please switch on your camera. No. See, he left. Okay, coming back. So when we talk about probability distribution mein, there are two kind of distributions. The first one that I have, that is called as a discrete distribution. Discrete distribution माने a random variable x can be called discrete if it takes countable values. Countable values माने finite values. Finite माने I can count. जैसे for example, if I ask you, I have tossed 5 coins. What is the maximum number of head? You can count. Maximum heads तो 5 ही हो सकते हैं. If I ask you that, okay, I am running a machine and it is producing 100 units, how many will be defective? You can go ahead and tell that कितने defective होंगे. So whenever we talk about anything which can be counted, that will be basically called as a countable set, a countable value. ठीक है, values जो finite होती हैं, which can be counted, number of defectives, number of heads in the coin, number of customers arriving in my shop, ठीक है, which can be counted, then it will be called as a discrete random variable. Whenever we have a discrete random variable, जब भी discrete random variable होगा, we will have something which will be called as PMF, probability mass function. Probability mass function माने probability mass function is nothing but probability associated with the random set. So random variable से related जो भी probability होगा, that will be called as probability mass function. ठीक है, so take an example. Let's say that I give you a very basic question कि x का there can be 3 values 0, 1, 2 and I tell you कि probability x is equal to xi माने यहाँ पे probability x equal to 0, यहाँ पे probability x equal to 1, यहाँ पे probability x equal to 2. I have given you these probabilities. ये हो गया 0.2, 0.5, 0.3. तो ये जो टेबल बना है, this table that I have created, इसको हमने बोल दिया probability mass function. This is called as probability mass function. ठीक है, this probability mass function will have two main properties. पहला, that each probability has to be non-negative. देख लो, I can see positive, positive, positive. And दूसरा, the sum of the probabilities have to be 1. You add them and it will be 1. The sum of the probabilities will be 1. So any random variable, कोई भी random variable हो, उसका एक PMF होगा as long as it is discrete. Discrete माने ये देखो, value है 0, 1, 2. 0.5 नहीं है, 0.2 नहीं है, 0.22 नहीं है. It's not a continuous random variable. It has just 3 values. Discrete values. 0 हो सकता है, 1 हो सकता है, 2 हो सकता है. And corresponding to that हमने उसका probability लिख दिया. This will be called as probability mass function. With respect to any probability mass function, हम एक और चीज create कर सकते हैं. We can also create one more thing, and that will be called as cumulative distribution function. इसमें we find the probability of x less than equal to some x. माने अब हम क्या करेंगे? What will we write here? In the first one, in this first one, we will write probability x less than equal to 0. यहां पे आएगा probability x less than equal to 1. यहां पे आ जाएगा probability x less than equal to 2. तो probability x less than or equal to 0, 0 ही रहेगा. 0 से कम तो I cannot see anything. There is nothing less than 0. तो ये तो equal to probability x equal to 0 हो जाएगा. अब probability x less than equal to 1 माने यहां पे probability x equal to 1 भी होगा और less than 1 भी होगा. Less than 1 क्या है? 0. So here less than equal to 1 will be what? 0.5 plus 0.2, 0.7. And less than equal to 2 माने क्या? All here. तो 0.2, 0.5, 0.3, ये हो जाएगा 1, right? So this becomes your CDF. Actually, it's a very interchangeable term. Cumulative distribution function भी बोल देते हैं. But हाँ, if you want to be specific, you will be right that you can say cumulative mass function, but books use them interchangeably. Cumulative में they really don't make a lot of distinction. But yes, you will be right. Term should be cumulative mass function. ठीक है? Is it clear? Okay. अब क्यूमुलेटिव मास फंक्शन या डिस्ट्रीब्यूशन फंक्शन का एक बहुत इंटरेस्टिंग प्रॉपर्टी है, बिकॉज वी आर एडिंग प्रोबेबिलिटीज नेक्स्ट 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 लेवल पे. यहां पे 0.2 था, 0.7, 1. सो यू सी इट इज more and more. 0.2, 0.7, 1. It means that we can say it is non-decreasing. It is non-decreasing. ये कम नहीं हो सकता. हाँ, it may happen that it will be no, it may happen that it may not increase. जैसे अगर ये वैल्यू 0 होता तो ऑफ कोर्स 0.2 प्लस 0 में आई वुड हैव गॉट 0.2 हियर, तो इंक्रीज नहीं हुआ, बट एटलीस्ट इट डिडंट डिक्रीज, राइट? सो इट इज नॉन डिक्रीजिंग इन नेचर. दिस इज अ प्रॉपर्टी ऑफ CMF. ठीक है? ओके. नाउ अनदर थिंग जो डिस्क्रीट वेरिएबल में होता है, दैट इज मीन. And this mean is called as expectation. तो एक्सपेक्टेशन ऑफ एनी वेरिएबल x, अगर हमें उसको प्रोबेबिलिटी के टर्म्स में लिखना है, इट इज समेशन xi pxi. ठीक है? इट इज समेशन xi pxi. सो आई एम गिविंग यू अ क्वेश्चन, फाइंड इट्स एक्सपेक्टेशन. You have x as 1, 2, 3. And corresponding probability is given to you as 0.2, 0.5, 0.3. Find expectation of x. Go ahead, give it a try. Good. All of you are right. So let's see. So just x into px कर दो. 0.2, 1, 0. So expectation of y will be expectation of 2x square plus 3. This will be expectation of 2x square plus expectation of 3. Constant का expectation constant रहता है. यहाँ पे coefficient comes out. This will be 2 expectation of x square plus 3. ठीक है. You have to find expectation of x square, multiply it with 2 and then add 3. Thank you, Anushka. Actually, the point is that they're not even part of the batch. I am 150% confident that people who are part of the batch will never say so. Because of this hard work that we put in, that is 150% guaranteed. These are people who are not part of the batch, but are joining in. Now, there is a lot of politics which goes behind running an institute, which I cannot share with the students. माने बहुत कुछ होता है. You see tons of random messages on daily basis. But anyways, we need to continue with what we are doing. हमारा अभी भी aim is the same. We need to score well, right? We need to work hard. So whatever happens in the background is fine. Just that in class, when something like this happens, see, we are giving so much weightage to it that we are discussing it. It's a wastage of students. और कुछ नहीं है. Otherwise, it's horrible politics out there. So it's not even worth discussing. ठीक है जी. Go ahead, try to answer this. So x square का expectation क्या होगा? So we find x square 0, 1 and 2 का square will be 4. Now we multiply x square with bx. Because मुझे expectation of x square चाहिए, right? So it will be 0. This will be 0.50 and this will be 1. So I will get the answer as 1 here. So expectation of x square will be summation x square into px. So ये हो जाएगा 1.5. Right? And I can go ahead and multiply it with 2 and add 3. बहुत important है. I think in one of the IITs, they gave, I think 2023 में किसी IIT में they gave a linear function या एक quadratic function and उससे related हमें expectation, covariance, correlation ये सब निकालना था. So it's very important that you understand that when we have to find expectation of a function, it's not very different thing. हम उस function में से variable का expectation निकाल के फिर हम उन coefficients को include कर सकते हैं. Mean of constant is not 0. Mean of constant is the constant. हाँ, variance will be 0. Correct. ठीक है. तो अब यहां पर if I come back to this question, can you find the variance in this question? Find variance. Expectation माने mean, variance is different. Variance अलग है. हाँ, variance is the spread जो हमने कल किया था. So to find variance मुझे पहले e of x square निकालना होगा. माने इस क्वेश्चन में I have to find x square और x square हो जाएगा 149. Then we have to find x square into px. So 1 into 0.2, 4 into 0.5, and 9 into 0.3. 4.9. So expectation of x square is 4.9. And expectation of x tha 2.9. So variance will be expectation of x square minus expectation of x ka whole square. Just find this value. Okay. So for 0.49, if all of you are saying so. ठीक है. हाँ जी, अब हम बात करते हैं कुछ और चीजों की यहाँ पे. So the variance of a constant is 0. Variance of constant into variable plus constant is variable का variance into a square, and variance of any variable is always positive, and variance of just ax is also a square variance of x. ये कुछ properties हैं which can be asked in exam. Right. So what kind of question they will give you in exam based on this? देखो. Let's say you're given that there is a variable x whose variance is 5. Find variance of 3x minus 7. ठीक है, तो ये जो भी हमारा एडिशन सब्ट्रैक्शन है, इट डज नॉट मैटर, सिर्फ द स्केलर क्वांटिटी मैटर्स. सो इट विल बी 3 स्क्वायर वेरिएंस ऑफ x. सो इट विल बी 9 into वेरिएंस ऑफ x, so it will be 45. अच्छा, what if I रिवर्स इंजीनियरिंग करें तो सपोज इफ आई टेल यू कि वेरिएंस ऑफ 7x minus 4, suppose this is 196, and I ask you find variance of x. Okay, how about this? तो ये तो what does it mean? This is origin, change of origin से फर्क नहीं पड़ता. So change of scale means 7 square variance of x is 196 ना. So variance of x will be 196 divided by 49. That's it. Okay, ठीक है. Now one last question, then we'll take a break. So if I tell you that variance of x is 9, variance of y is 4, you have to find variance of 2x minus 3y plus 4 if I am giving you x and y are independent. Dependent में covariance आता है. I'll tell you about that later, but just tell me if they're independent. तो यहाँ पे एक चीज थोड़ा समझ लो, then we'll do this. तो if they ask you find variance of ax plus by, पॉजिटिव भी हो सकता है ए बी, नेगेटिव भी हो सकता है, बट इफ दे टेल यू फाइंड वेरिएंस ऑफ ax plus by, it will be a square variance of x plus b square variance of y plus you will have So this is A and this is B. So 2AB, covariance between X and Y. This is the formula. Now, if X and Y are independent, अगर X और Y में कुछ relation नहीं है, then variance of AX plus BY को हम लिख सकते हैं A square variance of X plus B square variance of Y. माने covariance will become 0. So here, अगर I am given A and B are independent, तो पहले तो first of all this does not matter. Remember, ये constant है. So we can say that this will be variance of 2x minus 3y. 4 तो can be eliminated. And when I open this, so I will get 4 a square minus 4 variance of x plus 9 variance of y minus, because यहाँ पे एक minus का sign है, so this will become minus if there is a minus here. So it will be minus 2ab, 2 into 2, 4 into 3, 12 covariance between x, y. And when x and y are independent, अगर x और y independent है, so this covariance will become 0. So you will go ahead and you will get 4 variance of x plus 9 variance of y. So it will become 4 into 9 plus 9 into 4. ठीक है, this is very important from exam point of view. बहुत ज्यादा important है ये. Again, last year के IITs, last year के GATE, CUET, in fact, even in the last year papers of your UGC NET and RBI, ये most commonly asked question exam में. Yes. ठीक है, we'll take a break now. Okay, we'll start there. So the first distribution that we want to go ahead and we want to do, उसको हम बोलते हैं Bernoulli distribution. Bernoulli is where there are only two outcomes. One is success and one is failure. Success can be represented with 1 and failure can be represented with 0. Probability of success can be P and probability of failure can be 1 minus P. In case of Bernoulli, इसका जो mean होता है, mean is P and its variance is P into 1 minus P. Right? जैसे tossing one time, coin single time, ठीक है? Decision like whether you want to attend a meeting or not attend, yes, no, ठीक है? या pass and fail experiment, ठीक है? So this is where you do only one time and there is success या failure, तो उनको हम बोल देते हैं Bernoulli distribution, ठीक है? The other one which we go ahead and which we have, that is basically called as your binomial distribution. Now, when we talk about binomial distribution is the manifold of Bernoulli. मतलब एक बारी करने की जगह we do it many times. Like in Bernoulli, we are tossing coin once. Binomial में we will toss coin n times. ठीक है? Bernoulli में we are deciding once, success or failure. Binomial में we will decide n times. So in this, the probability of any x is equal to x becomes ncx p to the power x q to the power 1 minus x, where p is probability of success and q is probability of failure. ठीक है? The mean in this case becomes n into p and the variance of this becomes n into p into q. This is called as your binomial distribution. ठीक है? A binomial distribution is basically one distribution which is most commonly used for solving numerical. You will notice that towards the end sorry, n, not 1, because n trials are there. You will notice that towards the end of these notes, I have gone ahead and I have mentioned the relationship between different distribution. उनको अच्छे से पढ़ लेना. When binomial becomes approximately normal, when the binomial becomes approximately exponential, ये वाला जो relationships है, I have mentioned them in the notes, and I want all of you to go ahead and read those notes very carefully. Okay. Now, another thing which is very important here is the formulas of mean and variance of all the distributions. So you have to make sure कि exam में जाने से पहले you prepare a formula sheet of all distributions, and you go ahead and you write the mean and variance of all these distributions which can come in exam. Okay. So let me give you a few questions. You try to solve them. So, suppose you are given that a student answers true false questions by guessing. And let x be 1 if the answer is correct and 0 if answer is wrong. Right? And he is doing it by guessing. माने guesswork में correct or wrong का probability half होता है ना? So they have not mentioned the probability, they have said that he is guessing. Find expected value of x, find variance of x, find standard deviation of x. Give it a try. Yes, what will be the answer? बहुत सिंपल है. ठीक है, good. Yes, all of you are right. तो basically अगर वो बोले by guessing, so in guessing, what do you have to go ahead and do? In guessing, you have to go ahead and you have to simply assume that the probability will be 1. The probability will be 1. So in such cases, you have to go ahead and you have to simply say that the probability of x equal to 1, this will be, sorry, half, and probability x equal to 0 will also be half. इक्वल प्रोबेबिलिटी होगा. ठीक है. अब एक्सपेक्टेड वैल्यू ऑफ एक्स हमें पता है यहाँ पे, इट्स सिंपली पी, प्रोबेबिलिटी ऑफ सक्सेस. वेरिएंस ऑफ हाफ इज पी इंटू क्यू, सो हाफ इंटू हाफ, दिस इज 1/4, and standard deviation is under root of 1/4, so 1/2. So all of you are right who are saying 1/2, 1/4 and 1/2. ठीक है, correct. Now let us go ahead and let us try to answer another question. So the question is that you have a coin which is biased, right? And probability of head is 0.6, right? And it says that a game is played, right? In which you get 10 rupees if head comes, right? And you pay 6 rupees if tail comes. right? You have to find expected payoff, right? And you have to find variance of the payoff. Give it a try. You can use normal variance, but अगर हमें in shortcut पता है, formula पता है variance का, why will we not use that directly? हाँ जी. What do you think is the answer? Okay. How about others? Okay. Good. So let's see. So probability of head is 0.6. And it says you win 10 rupees when it is head and you pay 6 rupees when it is tail. So money, what will be your expected payoff? With 0.6, you win 10 rupees, and with 0.4, you lose 6 rupees. यही तो expected payoff होगा, isn't it? So just find this value. Just find this value. Whatever this value is coming out to be, that's your expected value. So all of you are saying 3.6, so I will write that as answer. Now let's talk about the variance. तो variance क्या था? Variance was variance of payoff. ठीक है, तो let the payoff be y. तो variance of payoff will be expected value of y square minus expected value of y whole square. ये हो सकता है, right? So expected value क्या आया है? Expected value is this multiplied with this and this multiplied with this, right? So if I have to find the variance of y, the variance of the payoff, so I can simply go ahead and say E of y square. E of y square will be summation y square into px माने 10 square into probability. Probability क्या है? What's the probability? 0.6 plus minus 6 square into 0.4. You solve this, you'll get an answer. So it will be 100 into 0.6, 36 into 0.4. कुछ आंसर मुझे बताओ यहाँ पे क्या रहा है, and you subtract 3.6 का whole square from it, minus EY whole square. So what answer are we getting here? How about other? Everyone is getting 61.44. Is everyone getting 61.44 the answer? Yes. Yes, no, slept. Okay, 61.44. ठीक है, सो दिस इज योर बर्नूली. ठीक है, अब बर्नूली के बाद हम आगे आते हैं टू द नेक्स्ट डिस्ट्रीब्यूशन विच इज बाइनोमियल भी हो गया. सो द नेक्स्ट वन विच आई वांट टू कम टू दैट इज कॉल्ड एज पॉइजन डिस्ट्रीब्यूशन. अब जब हम पॉइजन डिस्ट्रीब्यूशन के बारे में बात करते हैं, पॉइजन डिस्ट्रीब्यूशन इज एनी डिस्ट्रीब्यूशन वेयर योर मॉडल्स आर ओवर अ फिक्स्ड इंटरवल. एंड पॉइजन का हमारा फॉर्मूला हो जाता है प्रोबेबिलिटी x इज इक्वल टू e टू द पावर माइनस लैम्डा लैम्डा टू द पावर x बाय x फैक्टोरियल, where x can be 0, 1, 2 and so on. And lambda is called your mean. ठीक है, and expected value of x is also lambda and the variance of x is also lambda. ये हो जाता है हमारा पॉइजन डिस्ट्रीब्यूशन. लेट अस गो अहेड एंड लेट अस do some numerical on Poisson distribution. So what kind of questions can be given to you in exam? Suppose I tell you that there is, अच्छा इसमें ना आपको कैसे आइडेंटिफाई होगा कि पॉइजन डिस्ट्रीब्यूशन यूज करना है. इन एग्जाम वो ऐसा कुछ वर्ड यूज करेंगे, एवरेज रेट. जैसे एवरेज वर्ड पढ़ो डिस्क्रीट में माने पॉइजन है. सो फॉर एग्जाम्पल इफ आई टेल यू अ कॉल सेंटर calls at an average rate of 3 call per minute. देखो एवरेज रेट. ठीक है, and x represents number of calls in 1 minute. Find probability that x is 0. माने 0 calls in 1 minute. So how will we do this? Just use the formula. Probability x equal to 0 will be e to the power minus lambda lambda to the power x by x factorial. तो ये क्या हो जाएगा? e to the power minus lambda. lambda क्या है? Average. Lambda to the power x. x क्या है? Number of calls in 0 minute, which is 0 upon 0 factorial. Remember बेटा 0 factorial is 1. तो ये हो जाएगा e to the power minus 3 into anything to the power 0 is 1 by 1. E to the power minus 3 will be your answer. Is it clear? E to the power minus 3 will become the answer to this question. Now, another question, all of you will do it yourself. Accident at a crossing. Follow poison with average of 2 per day. Find probability of at most 1 accident in a day. करो बेटा. Find probability of maximum 1 accident in a day. Go ahead, tell the answer. How about others? Quick बेटा, quick. इसमें इतना टाइम नहीं लेना, ये 1 मिनट से ऊपर के क्वेश्चंस नहीं है. At most 1 accident माने क्या? या 0 एक्सीडेंट होगा या 1 एक्सीडेंट होगा. 0 एक्सीडेंट माने प्रोबेबिलिटी x इज 0 एंड 1 एक्सीडेंट माने प्रोबेबिलिटी x इज 1. x0 माने क्या? e टू द पावर माइनस लैम्डा, लैम्डा टू द पावर x बाय x फैक्टोरियल. e to the power minus lambda, lambda to the power x by x factorial. So e to the power minus 2 plus e to the power minus 2 into 2, that means 3e to the power minus 2. Done. ये आंसर है. This is the answer. Rest everything is incorrect. Okay. Now I'll give you a little tricky question. Try this. तो अब है that a machine, it produces defect at rate of 4 per hour. Find probability of exactly 3 defect in 30 minutes. Three defect in 30 minutes. Hanji, give answer to this one. Three defect in 30 minutes. So isme what's the trick? The trick is that you have to tell in terms of minute. And yahan pe is given in hours. Think that and then answer. Yes. बेटा क्विक करने हैं ये. दिस इज नॉट मोर देन 1 मिनट. एक एक मिनट में होने चाहिए ये क्वेश्चंस. So let's see. So 30 minute means 30 by 60. Half hour. Right? So I have converted this in terms of hours. You have to convert that in hour. Yeah, you have to convert everything in minute. Only then you will solve. So probability is asking, I want to check for exactly 3 defects in half hour. So it will be e to the power minus lambda, lambda to the power x by x factorial. अब देखो, machine produces 4 in 1 hour. How many average defects are there in 1 hour? In 1 hour, defects are 4. But question is asking for half hour ना. So in half hour, average defect will be 2. तो lambda का value 2 होगा यहाँ पे. This will be the answer. Doubts? Clear? Is it clear? Any doubt? Anyone? ठीक है. So answer will be 2 into 2, 4 into 2, 8, 3 into 2, 6, e to the power minus 2. Okay. Taking 6 defects in 1 hour. Well, you can, but why would we want to do that? मतलब कर सकते हो, does not matter if you want to convert everything like that. But the question is that the question has strictly asked me 3 defects in 30 minutes. I would rather convert this according to what 30 minutes average will be, not the other way around. Answer will be same, but technically we should be doing it in this way. Yes, so if it is something where you have to fill in or या e का value नहीं दिया हुआ, so there will be two things. So all of us know that the value of E, right? You just have to use that value of E in the calculator and you will get an approximate answer. And IIT and GATE में answer is never a single digit. It's an interval. So I know कि E का value it is 2.178. So I will do to the power minus 2 into 8 by 6. I will find this value. Right? Usme they will mention approximated to 2 digits and they will give you answer in an interval. So if your answer is within that interval, it will be correct. So don't worry, utna consideration they will have. Okay. ठीक है. Now let us go ahead and do one last question on this. So you're given that emails arrive with an average of 5 per hour. ठीक है. And X is number of emails in 1 hour. You have to find probability that X is 3 given X is more than equal to 1. Give it a try. हाँ जी. What will be the answer to this one? Find conditional probability. तो क्या बोल रहे हैं? We have to find probability x equal to 3 given x is greater than equal to 1. तो हम कह सकते हैं probability of A given B, this will be probability A intersection B upon probability of B. इसको मैं कह सकती हूँ this is probability x equal to 3 given x is greater than 1 intersection upon probability x greater than 1. अब एक बात बताओ, x greater than equal to 1 means what? If this is 1, so everything more than 1. Man, it can be 1, it can be 2, it can be 3, it can be 4, it can be 5. And I am doing its common with x equal to 3. So what is the common part? एक है x equal to 3, एक है x greater than equal to 1. So common part is simply x equal to 3 upon probability x greater than equal to 1. अब देखो x greater than equal to 1 is difficult to solve क्योंकि यहां पे हम लेंगे x1, x2, x3, x4 till infinity. तो probability x greater than equal to 1 को I can say 1 minus probability x equal to 0. 0 मेल्स आए उस दिन. So probability x equal to 0 will be what? It will be e to the power minus lambda, lambda to the power x upon x factorial माने e to the power minus 5. तो ये हो जाएगा denominator will be this. And x equal to 3 will be what? It will be e to the power minus 3, 3 to the power, sorry, e to the power minus 5, 5 to the power 3 by 3 factorial. So numerator will become this and denominator will become this. This is the answer to this question. Any doubts? Anyone, any doubt? प्लीज आस्क, ये आएगा एग्जाम में. दिस इज वेरी कॉमन क्वेश्चन इन एग्जाम. ओके, कॉमन एरिया पार्ट, ठीक है. सो जस्ट थिंक अबाउट इट. सी, इंटरसेक्शन मीन्स कॉमन. एक टेल मी समथिंग. वी नो कि नंबर ऑफ ईमेल्स इट इज डिस्क्रीट, तभी तो आई एम यूजिंग पॉइजन डिस्ट्रीब्यूशन. So when I say find probability x greater than equal to 1, it means what I am asking you. क्या पूछ रहा हूं मैं आपसे? Find probability of emails either one or more than one. So it means I'm asking you that number of emails can be 1, number of emails can be 2, number of emails can be 3, and so on. अच्छा, पॉइजन का एक प्रॉपर्टी है that x is always positive. नंबर ऑफ ईमेल्स तो पॉजिटिव ही हो सकता है ना. नंबर ऑफ विजिट्स टू अ शॉप विल बी पॉजिटिव ना. सो दीज थिंग्स आर ऑलवेज पॉजिटिव, ये हमेशा पॉजिटिव होती है. सो नाउ व्हाट द क्वेश्चन इज सेइंग इज दैट so probability x greater than equal to 1 is 1 plus 2 plus 3 and so on. Now I am asking probability x equal to 3 intersection x greater than equal to 1. Right? So intersection means you find the common part. When we have to find intersection between A and B, we find the common part between A and B. So here when I have to find the intersection between probability x greater than equal to 1 and x equal to 3, so what is the common part between 2? X greater than equal to 1 में ये सब कुछ है, and x equal to 3 is only this. So when I find the intersection between the two, common between the two, it is simply probability x equal to 3. So that is the numerator. Ki probability x equal to 3 intersection x greater than equal to 1 is simply probability x equal to 3. And denominator mein I have probability x greater than equal to 1. Ab the denominator is a bit difficult to solve. Kyun? Because usme we are including probability of x equal to 1 plus 2 plus 3 plus 4 plus 5 and so on. तो difficult हो गया solve करना. So because that is a little difficult to solve, हम क्या कह रहे हैं? We are saying that probability x greater than equal to 1 is nothing 1 minus probability x equal to 0. You just remove 0 males का probability and it is done. है ना? So once we remove 0 males, we will get the same answer. And what is the probability x equal to 0? Use Poisson distribution. E to the power minus lambda, lambda to the power x by x factorial. So probability x equal to 0 will be e to the power minus 5, 5 to the power 0 by 0.5. Is it clear now? I hope it's clear. कोई doubt नहीं है. ठीक है. So these are some of the questions related to Poisson. Now let's go on to the next part, and we want to talk about one last distribution here, and that is basically, अच्छा, not one last, मतलब बहुत सारी सकती हैं, but this is the only ones which are important. बाकी भी I have included in your assignments, in your notes, which you can go ahead and revise if time permits. ठीक है? But I just want to do geometric with you. I'll do negative binomial also, चलो, but others you can see on your own. देखो, geometric में the mean is 1 by p and the variance is q by p square. अच्छा, we'll make a table. That will make things easy. Before I explain this, बना लो एक बारी. Make this table with me. So mean and variance. ठीक है? So Bernoulli, binomial, Poisson, geometric, negative binomial. ठीक है? That's it. That's it, you should know. So P into 1 minus P. np, n into p into 1 minus p, lambda, lambda, 1 by p, q by p square. q is nothing but 1 minus p. ठीक है? And negative binomial में r by p and rq by p square. This is the table which you have to remember to solve the questions. ठीक है? This is r into q by p square. Q divided by p square. लैम्डा इक्वल टू, जैसे अभी हमने किए थे क्वेश्चंस, लैम्डा विल बी द मीन गिवन टू यू ना. जैसे यहाँ पे लिखा था ईमेल्स अराइव एट एवरेज ऑफ 5 per hour, तो लैम्डा इज 5. यहाँ पे इट सेड दैट मशीन प्रोड्यूसेस एवरेज 4, तो लैम्डा वाज 4. सो लैम्डा इज दैट एवरेज. No, there was no other formula. That's it. These are the formulas. Huh, sometimes what will happen, na, they will ask you to use Poisson, but they will give you NP. So you can use that lambda can be found by n into p. But otherwise, no. Lambda will be given to you in exam. Fourth, what is fourth distribution? This is geometric. This is 1 by p. This is q divided by p square. This is negative binomial. This is r divided by p. And this is r into q by p square. ठीक है, अब ज्योमेट्रिक करते हैं. So geometric basically goes ahead and says that you need the first success. So number of trials before first success. Mane, I'm asking probability of x is equal to x. ठीक है? So इसमें हम क्या कह रहे हैं कि suppose suppose success is a head for me and I need head in the 5th toss of the coin. तो first 4 tosses में I need failure. So I need tail, 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 tail and then head. ठीक है? So tail का probability is suppose Q and head का probability is suppose P because head is success. तो पहले का हो गया probability Q, second का probability भी Q, third का probability भी Q, fourth का भी Q and last का P. So you will get Q to the power 4 into P. This is the general formula. The formula of probability x equal to x, this is simply P into Q to the power x minus 1. तो जैसे if I need head in the 5th time, मुझे अपना success 5th toss में चाहिए. So it means that here I will have Q to the power 5 minus 1 into P. So P into Q to the power 4. माने पहले 4 will be failure. So Q, 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 Q. And last will be success. So it will be P. Is it clear? And geometric distributions have memoryless property. Memoryless property का माने क्या है कि probability x greater than s plus t given probability x greater than s is simply probability x greater than t. So this is about geometric distribution. बहुत सिंपल है ये सारा डिस्ट्रीब्यूशंस. आपको बस एक एक दो क्वेश्चन इनके बेसिस पे यू हैव टू डू एंड बिलीव मी you will be able to score 100% in probability. So I'll give you a question. So let's say that you are given that there is say a coin, and the probability of head is 0.3. Find probability of getting head on the fourth toss. माने fourth में ही head चाहिए. You don't need it in the first three. You need it in the fourth one. Solve. Hanji, all of you are correct. So you need head on the fourth toss. So mane first three have to be tail. So 0.7, 0.7, 0.7, and then 0.3. You can put it in this formula also. Keep probability x as 4 will be p into q to the power x minus 1. So p is 0.3, q is 0.7, x is 4 minus 1, 0.3 into 0.7 to the power 3. ठीक है? So this is your probability. अब suppose the question goes ahead. ठीक है, whatever answer all of you are getting, if it's 0.1029, that's the answer. ठीक है? Now, suppose the question says that, question number B, that x is geometrically distributed with p 0.25. Okay. Find expected value of x and variance of x and standard deviation of x. करो ये करो. Use the formula sheet. Expected value of x होगा 1 by p. Variance of x will be good, q by p square. And standard deviation will be ठीक है. So this kind of questions can be asked in exam. एक last question ले लेते हैं. So a candidate clears interview with probability 0.2 and x is clearing first interview. Right? Before many attempts. Find probability that he would clear his first interview after 10 failures, given he already failed 7 interviews. ठीक है? I've tried to frame it as easy as possible. This is what the question is asking. कि you need to find probability x is greater than 10. मतलब उसका जो first interview clear होगा, the first interview he will clear is after 10, after giving 10 interviews, right? Given he has already given 7, he has already not cleared in the first 7, he has already exceeded giving 7 interviews. Now you have to find that it will exceed 10 also. So we know कि यहाँ पर we can use its memoryless property. तो probability x greater than 10 given x greater than 7, you can write this as probability x greater than 3. ठीक है? So probability x greater than 3 माने you will get your success after the fourth one, at the fourth one, या fifth, या sixth, and so on. You can just write this as 1 minus probability x less than equal to 3. तो ये हो जाएगा 1 minus, you will have x0, x1, x2, x3. Is it okay? Yes. So see, what has happened is here the question is asking, in fact, I can help you go further with it. ठीक है, no problem. तो देखो what the question is saying. The question is going ahead and saying that the person has given 7 interviews. उसने 7 interviews दे दिए हैं and the person has gone and cleared none of them. So we know that person started, he has given the first 7 interviews and he has failed. Right? But he can clear the 8th one. He can clear at the 9th one. He can clear at the 10th one. Question is asking what is the probability he will clear his first interview after 10 failures. अभी तो उसने 7 ही दिया है, but he's asking, question is asking that he will get his success only after the 10th one. So what is the probability कि आपका जो success आएगा वो 10th के बाद आएगा, given कि आप 7 interviews दे चुके हो and you haven't succeeded. So probability of success, X represents the first successful interview. So when will your first successful interview be after 10th one, given कि you have already crossed 7? So इसमें we use the memoryless property of geometric distribution, which says that probability of x greater than s plus t given st is the difference. तो जब भी हमारे पास ऐसा कंडीशनल प्रोबेबिलिटी निकालना होता है इन ज्योमेट्रिक डिस्ट्रीब्यूशन, वी जस्ट से दिस इज इक्वल टू प्रोबेबिलिटी x ग्रेटर देन द डिफरेंस 10 minus 7. So this becomes probability x greater than 3. This is what we have done. We have found out probability x greater than 3 directly. Ab, in fact, there is another formula which you can go ahead and use for geometric distribution. And what is that formula? That formula goes ahead and says that probability x greater than any t is just q to the power t. Is just q to the power t. When you will solve it, तो उसका आंसर हमेशा q to the power t आएगा. So which means that in this case, if I have to find probability x greater than 3, this will simply be q to the power 3. That means 0.8 to the power 3. That's it. Shouldn't we take 11 as the first success? No. So the question says that he would clear his first interview after 10 failures. 11th is also after 10 failure, but 12th is also after 10 failures, right? So the framing of the question that I have done, maybe thoda wording because I just framed it myself. What I intend to ask is that it is after 10 failures माने, so I could have rewritten it, इसको थोड़ा better कर सकते हैं, that at least 10 failures. हाँ माने the question that I am asking here is that what is the probability x is greater than 10 given x is greater than 7? I have at least 10 failures, या 11 failures, या 12 failures. So at least 10 failures is what I am happening. I want you to use the memoryless property to learn this property here. Is it fine? Can this be done by a negative binomial? No, because success is only once यहाँ पे, right? It is only happening after many failures. Success सिर्फ एक ही बार ही आ रहा है. You clear the interview and you get the job. Then you don't clear the interview again. तो negative binomial नहीं आ सकता है. In the previous question, when x is greater than equal to 1, you used 1 minus probability x equal to 0. So I'm confused with probability x equal to 3. See, I don't know कि क्या confusion है, but just see here, huh? When we say probability x greater than equal to 1, in the other case जो हमने पहले किया था, in poison, तो poison का ये property है that x starts from 0. There is no negative x. So x is either 0, and since it is discrete, x can be 0, x can be 1, x can be 2, and so on till infinity. But numbers. ठीक है. अब जब हमें निकालना था probability x greater than equal to 1, माने हम 1 plus 2 plus 3 and so on करते. So उसकी जगह we did 1 minus 1, क्योंकि total probability is always 1, minus we eliminate this x equal to 0. तो जब हम टोटल में से वी एलिमिनेट दिस तो हमें ऑटोमेटिकली मिल जाता है. सो दैट इज वाई व्हेन आई सेड प्रोबेबिलिटी एक्स ग्रेटर देन इक्वल टू 1, यहां पे मेरे को आ गया 1 माइनस प्रोबेबिलिटी एक्स इक्वल टू 0. दिस इज व्हाट वी डिड देयर. यहां पे भी सेम है. इफ आई हैव टू फाइंड प्रोबेबिलिटी एक्स ग्रेटर देन 3, माने आई एम एबल टू क्लियर माई इंटरव्यू ईदर द फोर्थ टाइम, या I am able to clear my interview the fifth time, या I am able to clear sixth time and so on till infinity. तो उसकी जगह पे I have written 1 minus probability x less than equal to 3, क्योंकि 4 onwards included है ना. So up to 3 we can subtract from 1, right? So I have to clear the interview. So it can be cleared in first chance, in second interview, in third, in fourth, and so on. So when I say probability x greater than 3, mane I am clearing from fourth onwards. And total is answer is 1, total probability. So if I subtract these, I get that. तो वो यहाँ पे किया है. 1 minus clearing in the 0 का इसमें जरूरत भी नहीं है. I've just written it for a general case. You cannot clear in the 0th time. तो 1 minus x equal to 1 फर्स्ट टाइम में आपने क्लियर कर लिया, सेकेंड टाइम में क्लियर किया, या थर्ड टाइम में क्लियर किया. ठीक है. Can you please show with first method what will be n? There is n. I didn't get. Which n? There is no n here now. The general formula in this case is this. You remember? ये था. There is no n in this. So we are saying that probability x as 1, I mean, which means I am clearing it in the first time, will be p into q to the power 1 minus 1. Probability x equal to 2 will be p into q to the power 2 minus 1. Probability x equal to 3 will be p into q to the power 3 minus 1. तो ये हो गया p, ये हो गया p into q, ये हो गया p into q square. And you add. Huh? So this will be your thing. Okay? Hanji, any other doubt here? Is it clear? ठीक है. ओके, ये मेमोरी लेस प्रॉपर्टी, बिलीव मी, इट विल बी आस्क्ड इन योर एग्जाम 150%। अगर ज्योमेट्रिक आएगा तो मेमोरी लेस आएगा ही आएगा, सो यू हैव टू अंडरस्टैंड दिस वेल। All, whatever we are doing in marathon is important. Now you cannot think of skipping anything after this. Okay, now let's talk about negative binomial. तो जब हम negative binomial के बारे में बात करते हैं, in negative binomial we actually go ahead and we ask, so जैसे binomial में we were asking about the number of successes, negative binomial में we ask the number of trials required to get some successes. So suppose if I tell you example के लिए that, अब so देखो, हमने बाइनोमियल में स्टेटमेंट्स देखना, हाँ, बाइनोमियल में हमने बोला व्हाट इज द प्रोबेबिलिटी ऑफ गेटिंग टू हेड व्हेन कॉइन टॉस्ड 3 times, सिंपल स्टेटमेंट था। देन व्हेन वी वेंट टू ज्योमेट्रिक, तब हमने बोला प्रोबेबिलिटी ऑफ गेटिंग फर्स्ट हेड बिफोर 3 tails when coin is tossed, माने आफ्टर टेल्स पहला हेड, फर्स्ट हेड, वर्ड यूज होगा फर्स्ट। देन व्हेन वी गो टू नेगेटिव बाइनोमियल, तब वर्ड यूज होगा व्हाट इज द प्रोबेबिलिटी ऑफ गेटिंग टू हेड बिफोर 3 tails। तो यहां पे भी बिफोर समथिंग यू वांट टू गेट समथिंग या आफ्टर समथिंग यू वांट टू गेट समथिंग, बट इंस्टेड ऑफ गेटिंग द फर्स्ट हेड, now you're asking for 2 heads, right? So the wordings will change, that's the only thing. We are not talking about the first head, यहाँ पे before की जगह actually it should be after 3 tails. So we are not talking about the first head, पहला सक्सेस की बात नहीं कर रहे हैं हम in negative binomial. We are talking about few successes after few failures. यहाँ पे first success, first head after 3 tails, तो we want tail 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 and then we need head. यहां पे ये पूछ रहा है क्वेश्चन, यहां पे क्वेश्चन सिंपल है कि आई हैव टॉस 3 टाइम, कभी भी 2 बारी हेड दे दो मुझे, यहां हेड दे दो, यहां हेड दे दो, डज नॉट मैटर, गिव मी एनी 2 heads. हियर क्वेश्चन इज सेइंग नो, आई नीड 3 tails, आई नीड फेलियर फर्स्ट एंड देन सक्सेस। एंड यहां पे व्हाट क्वेश्चन इज सेइंग कि आई नीड 3 tails before the second head comes. First head can come anytime, so that total number of successes are 2. So in negative binomial हम क्या बोल रहे हैं, that we need r successes, first success नहीं चाहिए, we need r successes before you complete your failures, right? So this is what the question is asking. So how do we solve this kind of questions? बहुत simple है. Let me give you a question for this. So ये जैसे for example in families, हाँ, suppose we say how many boys will be born before the second girl, how many girls will be born before the second boy. जब हम ये successes करते हैं but not the first success, right? That is basically your negative binomial. One second, let me look into the chat. Yes, these 5. Yes, you're right. When r will be 1, the first success, तो वो negative binomial will become geometric. General form of negative binomial. ठीक है, we'll do that. Okay. So, so the general form of negative binomial is probability x is equal to some x will be x minus 1, c r minus 1, p to the power r, 1 minus p to the power x minus r. इतना बड़ा समझने का जरूरत नहीं है. अभी जब I will do question, things will become clear. But you can write the general form. लिखो. So, a coin gives head with probability 0.4. Find that in that, let me frame properly. Find that seventh toss is third head. Seventh toss is third head. अब इसका क्या मतलब है, ध्यान से. हाँ, so I am tossing 7 times. 1, 2, 3, 4, 5, 6 and 7. अब सेवेंथ टॉस में आई नीड थर्ड हेड, माने यहां पे आई एम फिक्स्ड कि यहां पे मुझे हेड ही चाहिए. इन द सेवेंथ टॉस आई एम श्योर कि मुझे हेड ही चाहिए. सो आई एम श्योर दैट आई नीड सक्सेस. ठीक है. अब बचते हैं रिमेनिंग 6. हाउ मेनी हेड्स आई रिक्वायर टोटल? 3 हेड्स, जिसमें से आई नो कि थर्ड हेड यहीं पे आना चाहिए. सो रिमेनिंग आई नीड 2 हेड्स. सो आउट ऑफ रिमेनिंग फर्स्ट 6 आई नीड 2 हेड. व्हाट इज द प्रोबेबिलिटी ऑफ हेड? ये कैसे करेंगे? ये तो बहुत सिंपल है. यहां पे तो मैं बाइनोमियल ही लगाऊंगी दैट आउट ऑफ 6 आई नीड 2 हेड. सो 6 में से 2 हेड्स, probability of success to the power 2, probability of failure to the power 4. So this will become 6c2, 0.4 to the power 2, 0.6 to the power 4 into p. ये है 0.4. This will be your answer. Is it making some sense? Is it clear? Can you guys do a question yourself now? Okay. A salesman makes sale with probability. All of you should know this, 0.6. Find probability that probability 0.6 on a call. Okay. Find probability that sixth call will be second sale. That जो भी वो sixth call कर रहा है, on that he will make his second sale. Just solve it. Yes. How about others? Quick. So again, have a look. देखो. He's making 6 calls. So 1, 2, 3, 4, 5, 6. In the 6th call, he has to make his second sale. मतलब यहाँ पे he is making a sale. He is getting success. So in the remaining 5, जो पहला 5 calls हुआ है, उसमें he should make only 1 sale. तभी तो second sale will happen on the 6th call. Total he is making 2 sales. So in the first 5 sales, out of 5, he has to make 1 sale into probability of sale to the power 1, probability of failure to the power 4. यहाँ पे मैंने binomial ही लगाना है. What is binomial? NCR, P to the power R, Q to the power N minus R. वही लगा रही हूँ. That out of 5, he has to make 1 sale, probability of sale to the power 1, probability of no sale to the power 4, and the last one. अब इसका probability यहाँ पे sale ही है. So into P. Just put the value of P as 0.3 and Q is 0.7. Okay. Is it clear? Do you want me to repeat this? Is it clear to all of you? Okay. So always fix the last position for success. And remaining वालों में have the remaining success. माने अगर यहाँ पे second sale करना है 6th call पे, तो 6th call पे मेरा success है. And remaining 5 में I want 1 sale. So out of 5, I need 1 sale, P to the power 1, Q to the power 4, and last wala I need sale. So into P. Good. Okay. Sneha, what about you? You were confused. Is it clear now? ठीक है. Good. Now let's talk about continuous distributions. So when we talk about continuous distributions, सबसे पहला distribution which is important is your uniform distribution. ठीक है? Continuous distribution माने जो हमारा variable, random variable x है, it is continuous in nature. So continuity का मतलब क्या है? It can take any value. It can take any value from minus infinity to infinity. And since it can take any value, क्योंकि वो कोई भी value ले सकता है, probability of any one particular value is 0. क्योंकि इतना सारा numbers है, there are infinite numbers, the chances of taking one number, it is so less, so minute, कि at a single point we assume probability to be 0. तो continuity में the only thing which is useful is intervals. जैसे height of a student, जैसे time taken to complete exam, जैसे rainfall in a day, lifetime of a bulb, ये सब are continuous variables. Continuous variables में we go ahead and we show by probability density function PDF, ठीक है, and we represent it by small fx. PDF का कुछ properties है, that probability is non-negative. When you integrate it over the interval, you should get the answer as 1, right? And whenever I have to integrate between any interval, I can write it like this. ठीक है? Remember, जब हम PDF की बात कर रहे हैं, तो PDF is also at a point. Usually हम point पे बात नहीं करते हैं functions की. Therefore, we usually go ahead and we talk about a certain interval. माने आपने कभी नहीं देखोगे continuous में that they will ask you find at one point. ऐसा कभी नहीं होगा. They will always go ahead and tell you कि find the probability of x between -1 to 1. something like this. They will always talk about an interval. Then comes the cumulative distribution function, which is represented by capital Fx. Capital Fx का मतलब है that you take from minus infinity up to that x. So for example, if I ask you find f of 2, इसका मतलब हो गया कि मैंने माइनस इंफिनिटी से लेके 2 तक का सारा वैल्यूज तक उसको इंटीग्रेट किया. ठीक है. There is a property that when we integrate PDF, we get CDF, and when we differentiate CDF, we get back PDF. Right? So these are your questions which are very, very important from the point of view of exam. Similarly, sometimes exam में you will be already given PDFs and CDFs. जैसे if I ask you कि what is probability of X between A and B in terms of CDF, तो आप लिखोगे it is f of B minus f of A directly. In terms of CDF, we can go ahead and write it like this. एक्सपेक्टेड वैल्यू का फॉर्मूला अब चेंज होके हो जाएगा x इंटू एफ एक्स इंटीग्रेटेड. सो इंस्टेड ऑफ एडिंग, जब हम डिस्क्रीट में एक्सपेक्टेड वैल्यू निकाल रहे थे, वी वर डूइंग समेशन x इंटू प्रोबेबिलिटी. उसकी जगह वी विल नाउ इंटीग्रेट. एंड सिमिलरली जब हम बात करेंगे वेरिएंस की भी, तो वेरिएंस में जब हम e ऑफ एक्स स्क्वायर निकालते हैं, दैट विल बिकम एक्स स्क्वायर एफ एक्स dx integrated. So everything will go ahead and convert to integration instead of addition. Otherwise, concept wise, everything is the same. Okay, let's go ahead and take some numericals on these first. So question. बहुत सिंपल क्वेश्चन देती हूँ. सो यू हैव बीन गिवन fx is equal to k times x and x is between 0 to 2. You have to find k and you have to find probability of x between 0.5 to 1.5. Go ahead, give it a try. Okay, good, all of you. So, for people who are not able to join in, please tell them again to join in and ask them to put their batch names with their name. Probably that's the reason that they're not part of the class. Okay, so let's start. So, K, तो क्या करना होगा? That this is PDF. So you integrate this between interval given to you. So 0 to 2 and equate it to 1. So you get K. Integration of x square, x will be x square by 2 from 0 to 2 and equate it to 1. K 2 square by 2 minus 0 square by 2 as 1. K 2 square is 4 by 2 is 1. So K is half. All of you are right. K का value half आएगा. जब K half हो जाएगा, so your fx will become half into x. ठीक है. Now you have to find probability between 0.5 to 1.5. So I will integrate my function जो भी मेरा बना है from 0.5 to 1.5. So it will be half. Integration of x will be x square by 2. 0.5 to 1.5. 1 by 4. 1.5 square minus 0.5 square. Solve and get the answer. ठीक है? Is it clear? Okay. Now let's move on to the next question. So suppose you're already given that the CDF is x cube and x is defined between 0 to 2. Fine, just give me a second. I'm thinking. Okay, let's not do this. Just find probability that x is between 0 to 2. ठीक है, think, just do this. I was thinking only that I'm making some mistake because you're getting probability more than 1. Okay. So, which means it's not a valid PDF that I have created. So always check for valid PDF, huh? Mane, because I have to find between 0 to 2, so I will be doing f of 2 minus f of 0. So mane 2 to the power 3 minus 0 to the power 3, 8. Which is mathematically you have done correct, all of you have done correct. But probability क्योंकि more than 1 आ रहा है, तो it's a little incorrect in that sense. So yes, it should have been less than 1. I should have created 0.2. तब वो ठीक रहता. ठीक है. Anyways, this is how you solve. You just have to do this f of 2 minus f of this and directly put in the CDF function. कुछ integration नहीं करना होगा because CDF is directly given. That is what I intended to explain. So इसको हम 0.2 कर लेते हैं. And then this will be valid now. Okay, so one last question. So fx is equal to 2x. X is defined between 0 and 1. Find ex and variance of x. Give it a try. How's this CDF? Because दिया हुआ है. How नहीं? They have already given कि एक CDF function है. तो इसके corresponding अगर PDF निकालेंगे ना, so it is just differentiation of this. माने PDF would have been 3x square और उसको हम integrate करेंगे तो CDF आया होगा. So it's already given. It's capital ना? हाँ. Okay. So just do this one now. Find expected value and variance. I think I will need one more day for stats here because we won't be able to wrap up hypothesis testing today anyways. Maximum we'll have to end at probability and do the numericals related to that. So probably one more day we'll keep stats. Hanji, do it. So EX will become X fx dx. X 2x 0 to 1, 2x square 0 to 1. तो ये हो जाएगा 2x square माने x cube by 3 from 0 to 1, 2 by 3. ठीक है, so all of you are correct. अब बात करते हैं सेकंड का, which means we have to find variance. So variance of x will be e of x square minus e of x whole square. तो e of x square हो जाएगा x square fx dx माने x square fx is 2x dx. So 2x cube dx. So 2x cube हो जाएगा x to the power 4 by 4. And you have to integrate between 0 and 1. तो ये हो जाएगा 2 by 4. So put it here. This is 1 by 2 minus 2 by 3 whole square. So 1 by 2 minus 4 by 9. So 9 minus 8, 1 by 18. This will be your variance. Clear? Any doubt? Anyone? One last question. Median पे भी कर लेते हैं. So find median. So you are given fx is equal to 2x defined between 0 to 1. Find median of this distribution. तो median का property है that when you will integrate from 0 to median, you should get the answer as half. When you will integrate any PDF between 0 to median, you should get the answer as half. ये median का property है. So just use that property and get the answer. In case of CDF, there is no integration. Correct. क्योंकि CDF is obtained by integrating. CDF का meaning क्या है? So suppose if I have normal distribution defined between minus infinity to infinity, right, with center here, and I say find f of 3, not हाँ माने f of 3 तक निकालना है suppose. So 3 will be here. So f of 3 means you have already integrated this area from minus infinity up to 3 and you have got this. So you obtain this by integrating only. जितना भी बोलो उतने तक का area you find out and that becomes your cumulative. Right? So it's not that there is no integration. CDF is obtained after integrating PDF. जब हम PDF को PDF माने इसका एक फंक्शन दिया हुआ है, इस इक्वेशन दिया हुआ है कर्व का. But when we find the area under the curve from one point to another, then उसको हम CDF बोलते हैं. That is called CDF. Right? हाँ जी. So what about median? So you integrate 2x between 0 to m to get half. अब इंटीग्रेशन ऑफ x क्या होगा? x square by 2 between 0 to m and you get half. So put the upper, this 2 into cancels, put value of m minus value of 0, upper limit minus lower limit. So m square is half, so m will be root half. That's it. This will be your median. ठीक है. If all of you are saying answer is 0.70 this, then it's fine. अब हम आते हैं यूनिफॉर्म डिस्ट्रीब्यूशन पे. सो यूनिफॉर्म डिस्ट्रीब्यूशन, it has the following property that the probability is the same. Probability PDF is constant. ठीक है. So I can say that if the function is defined between 2 to 6, the probability of at each is the same. एक लाइन है. Instead of curve या कुछ और curve, the fx is the same. Okay. So how do we go ahead and how do we form this? Well, in this case, my probability fx is simply 1 upon b minus a, where b is the upper limit and this is the lower. So if I have to find fx will simply be 1 upon 6 minus 2, mane 1 by 4. That's the first thing. The second thing is that for uniform distribution, कैपिटल एफ एक्स माने क्यूमुलेटिव अगर हमें निकालना है कि ठीक है फाइंड द प्रोबेबिलिटी अप टू सम नंबर एक्स नॉट, तो वो हो जाएगा एक्स माइनस लोअर लिमिट अपॉन अपर लिमिट माइनस लोअर लिमिट. माने इफ समवन आस्क्स यू फाइंड प्रोबेबिलिटी ऑफ एक्स लेस देन इक्वल टू 4, तो दिस इज एफ ऑफ 4. तो ये हो जाएगा यू पुट 4 लोअर लिमिट upper limit minus lower limit. Then in this case, your expected value of this distribution, it is a plus b by 2. And इसका जो variance हो जाता है, that is basically b minus a whole square by 12. ठीक है. So do a question on this and wrap this up. So let's say that you are given that x is uniformly distributed between 2 to 8. First, find probability function of x. Second, find probability x is between 3 to 5. Third, find expected value of x. Fourth, find variance of x. Do it. So this will become 1 upon b minus a. Okay. When we have to find between 3 to 5, this can be written as f of 5 minus f of 3. F of 5 will be 5 minus lower upon upper minus lower. When we have to find f of 3, it will be 3 minus lower upon upper minus lower. So this will be 3 by 6 minus 1 by 6, 2 by 6, 1 by 3. When we have to find expected value, it will be a plus b by 2. So upper plus lower by 2, 10 by 2, 5. And variance, yes, all of you are correct. Correct. So when we have to find the variance, it will be b minus a whole square by 12. So 8 minus 2 whole square by 12. So 6 square by 12. So 36 by 12. So 3. Is it clear? तो वेरिएंस आ गया 3, एक्सपेक्टेड वैल्यू आ गई 5 एंड ये हो गया 1/3. ओके, नाउ लेट्स टॉक अबाउट एक्सपोनेंशियल. When we talk about exponential distribution basically are again related with time. You're right. Yes, that's right. You can equate to 0.5, 0.5, 0.75. Huh, that's right. Correct. Okay. So now when we talk about exponential distribution, exponential is again related with time, but just that now continuous होगा. So when we were talking about poison में भी हम average time rate, average rate की बात कर रहे थे, but that was discrete. यहाँ पे it will be continuous. तो यहाँ पे हमारा जो fx बनता है, fx is lambda e to the power minus lambda x, and we assume again that since it is related to time, x is only greater than equal to 0, where lambda is called the rate parameter. Okay. Another thing which is important here is the CDF. CDF भी आपको याद ही रखना है. So the CDF function is having a formula 1 minus e to the power minus lambda x, where x is greater than equal to 0. So this is your PDF and this is your CDF. Exponential distributions का जो mean होता है, average होता है, that is 1 by lambda. The variance of exponential distribution is 1 by lambda square. The standard deviation is under root of this, माने 1 by lambda. ठीक है. So एक property है exponential distribution का, which you can see, जो Poisson में भी था, that mean and standard deviation, they are equal here. This is also 1 by lambda and that is also 1 by lambda. Exponential distribution also have memoryless property. जो geometric में हमने पढ़ा था, that probability of x greater than s plus t given x greater than s is simply probability of the difference. These are some of the things in exponential distribution. ठीक है? Just remember that exponential and Poisson दोनों time से related हैं, but Poisson बताता है number of events, वो discrete है, number बताता है, whereas exponential time में बताता है, tells about the waiting time until the first event. So exponential will always be in terms of time because time is continuous, but Poisson will be in terms of number of events. That is the difference between the two, right? Okay, so let's go ahead and take some numericals on this. So you're given x is exponentially distributed with lambda 0.4. Find probability x is greater than 5. Give it a try. Yes, it will be mentioned, or you have to sometimes identify. जैसे अभी हमने किया था, right? We had made that table to see कि Poisson, negative, binomial, and बाकियों में what's the difference in the wording. So when they say the first success, then we know geometric will be used. When they will say third success in 5 trials, तो क्या use होगा? So sometimes you have to also identify based on the words. हाँ जी, do this. So probability x greater than 5. इसको I can write 1 minus probability x less than equal to 5. इसको I can say 1 minus f of 5, क्योंकि ये up to 5 सारा include कर रहा है, तो ये cumulative हो गया. And if I use this formula, so I know f of 5 will be 1 minus e to the power minus 0.4 into 5, right? X की जगह पे I have plugged 5 and lambda की जगह पे I have plugged 0.4. So this will be 1 minus e to the power minus 2, right? So now I can just put it here, 1 minus f of 5 की जगह I'll plug this value. So this will be e to the power minus 2. And this will be my answer. Clear? Any doubt? Anyone? Okay. Do this question. X follows exponential distribution with factor lambda. Probability x greater than 4 is 0.2. Find lambda. हाँ जी बेटा, do it. Sorry, this is lambda.
From that. No. Aja. Sure. Easy, man.
Okay. I'll explain this. क्या बोल रहे हैं देखो. पहले हम ये निकाल रहे हैं, probability x greater than 4. Greater than निकालना is always difficult, तो you will convert this in less than. So probability x greater than 4 को you will write 1 minus probability x less than equal to 4. Always convert this in less than, always. So this will become 1 minus f of 4. अब f of 4 निकालने के लिए I will just plug it in this formula. So f of 4 means x will be replaced with 4. So I will get 1 minus e to the power minus 4 lambda. This is the value of f of 4. You will plug this value of f of 4 here. And you will get e to the power minus 4 lambda. ये आपका आंसर यहाँ पे आ गया. So we have found that this side, this is e to the power minus 4 lambda. And this is equal to 0.2. बस अब कुछ नहीं करना. I have taken log on both sides and use the property that ln m to the power n is n ln m. So this power comes down. And ln e is 1. So ये 1 हो गया. And then just found out what lambda will be. अच्छा, एक और चीज कभी कभी एमसीक्यू एग्जाम में होता है. दिस आई नो ln m to the power n is n ln m. तो ये जो -1 है यहाँ पे, दिस कैन गो इन इट्स पावर ना, बिकॉज पावर को ही तो नीचे लेके आते हैं. So I can write this as ln 0.2 to the power -1 by 4. That means I can write this as ln 1 divided by 0.2 by 4. So I can write this as ln 5 by 4. Sometimes you will notice in MCQ, you will be given like this. This is 4 is in the denominator. So sometimes in MCQ, you will be given this option. And you will not know कि ये option कहाँ से आया है. So they have just taken this -1 up in the power and then just solved it. Is it clear? I want you all to look into this question thoroughly. हाँ, so usually we use ln. लॉग भी यूज कर सकते हो, मतलब कुछ डिफरेंस नहीं है, बट जो भी बेस यूज करो इन कैलकुलेटर यू हैव टू यूज प्रॉपर्ली. As long as you see e, you will use ln because ln e is simply 1, right? So you use ln over log in that case. Okay, so with this we come to end of exponential distribution as well. Now we'll give a halt to the session here today. One more class I will take now. Usme we will go ahead and we will do normal distribution. And when we do normal, उसी में we will introduce standardization कि Z को standardize कैसे करते हैं. And we will also do hypothesis testing in that, all kind of hypothesis testing. And with that, we will wrap up statistics completely. Okay. After today's class, I will again attach an assignment as I did after yesterday's class on your portal. पहले वो वाला assignment करना जो कल की क्लास में था. It has 199 questions. And then do today's assignment based on all the distributions. If you look into the notes में towards the end, I have done some topics which I haven't covered today. जैसे for example, there is a topic on time series analysis, there is a topic on index number, and there is a topic on hypothesis testing. ये 3 topics we will take in the next session of statistics before we wrap stats completely. Okay, so you can skip revising these. If you know them, revise them, nothing like that. But अगर नहीं आता, you can skip them. And I want you to make sure कि उससे पहले तक whatever is in the notes, including these numericals which are posted on within the notes like this, including all properties of probability distribution, everything you have to revise before the next marathon. Make stats the strongest subject after the marathon. ठीक है? Okay, thank you.